Good day, students. I'm Ma'am Diane, and today we're chemistry detectives on a mission. Your goal is to make sure no atom goes missing. First clue. What is a chemical reaction? A chemical reaction is when substances change into new ones. And we represent this using a chemical equation, where reactants become products. This is the law of conservation of mass, meaning matter is not created and not destroyed. So, every atom we start with must still be there at the end. Remember, according to the law of conservation of mass, before we solve the case, here's our detective toolkit. Let's read the symbols in an equation. The arrow means yields or produces. A double arrow means the reaction can go both ways or reversible. Sometimes you'll see heat, light, or a substance written above the arrow. These are conditions needed for the reaction. Reactants, left side of the equation. Products, right side of the equation. Subscript. This is the small number written below, like in H sub 2. It tells how many atoms are in one molecule. The subscripts in a formula are never changed. Coefficient. This is the number in front, like 2H sub 2. It tells how many molecules you have. The coefficient is a whole number written before the chemical formula of the substance to make the chemical equation balance. It serves as the multiplier of the atoms in the formula. Quick note: some elements naturally exist as pairs, like hydrogen, oxygen, and nitrogen. These are called diatomic molecules. And here's something you must never forget. We only change coefficients. We do not change subscripts. Most simple equations can be balanced by inspection. This involves examining the elements on both sides of the equation and adjusting the coefficients until an equal number of atoms of each element on both sides is achieved. Let's investigate our first case. Hydrogen gas plus oxygen gas yields water. Step 1. Count the atoms. Look at each element on both sides of the equation. Count how many of each type you have on the reactant side and the product side. Reactants: hydrogen 2, oxygen 2. Products: hydrogen 2, oxygen 1. We have a problem. Oxygen is missing on the product side. So, we fix it using coefficients. If there is no coefficient or subscript, it is understood that it has 1. Now, let's check again. Reactants: hydrogen, 4. Oxygen, 2. Products: hydrogen, 4. Oxygen, 2. Balance. First case, closed. Detectives, here's your next case. Nitrogen gas plus hydrogen gas yields ammonia. Can you balance this equation and solve the case? Let's examine the evidence. Count the atoms on each side. The atoms don't match. Let's start with nitrogen. On the left, we have 2 nitrogen atoms. But on the right, we only have 1. So, we add a coefficient of 2 in front of NH sub 3. Now, nitrogen is balanced. Next, let's check hydrogen. Now, we have 6 hydrogen atoms on the right, but only 2 on the left. So, we adjust the coefficient of hydrogen. To get 6 hydrogen atoms, we need 3 H sub 2. Let's check everything. Balance. Case closed. Notice the process. We balanced one element at a time and adjusted coefficients only. Think of it like a scale. Both sides must be equal. Every atom counts, no exceptions. So, always remember, count the atoms, compare both sides, adjust coefficients only. Now it's your turn, detective. Sodium plus chlorine gas yields sodium chloride or table salt. Can you balance it? I know you can. Thank you for watching. I hope you learned something today. Please like, share, and subscribe to our channel for more educational videos. Thank you so much.